After understanding the overview of artificial intelligence, let's take a look at the technical and application fields of artificial intelligence. In this diagram, we can intuitively see a domain of applications for artificial intelligence and some directions related to the technical fields it involves. In the upper-level application field direction, we can see different industries such as manufacturing, finance, education, and healthcare, as well as smart cities, which are large comprehensive solutions scenarios. In the technical field, we mainly see major directions such as computer vision, knowledge learning planning optimization, natural language processing, and so on. There are also some research schools related to artificial intelligence, such as the symbolic and connectionist approaches we introduced before, which are related to our deep learning algorithms here. As we move to the core of the middle layer, we will see the main artificial intelligence algorithms manifested in the field of machine learning, such as support vector machines, random forests, logistic regression, linear algorithms, and so on. Here is a distribution map of the application technology of artificial intelligence enterprises at home and abroad. From this map, we can intuitively see that computer vision, cloud processing, and natural language processing occupy a large part of the research scope. We can see that computer vision, as the name suggests, is the science of studying how to make machines see. Cloud processing, on the other hand, researches the process of speech production, the statistical characteristics of speech signals, speech recognition, machine synthesis, and various processing technologies related to speech perception. Natural language processing, on the other hand, is the discipline of using computer technology to understand and apply natural language. Next, we will introduce their application scenarios from the perspectives of cloud processing, in computer vision and natural language processing. Here you will see that computer vision is relatively the most mature technology in the field of artificial intelligence. Computer vision, a research topic, mainly includes image classification, object detection, image segmentation, object tracking, text recognition. In the future, computer vision is expected to enter an advanced stage where it autonomously understands, analyzes, and makes decisions, truly endowing machines with the ability to see. For example, in hot areas like autonomous driving of unmanned vehicles and smart home scenarios, computer vision can bring greater value. Here we will see some common applications of artificial intelligence in daily life. In terms of machine vision, it is reflected in our electronic attendance system and customer flow analysis. From this customer flow analysis, we can analyze the gender ratio of our customers and whether they are new or returning customers. In the next scene, we will see applications such as intelligent album photo search. For example, in our smartphones, the intelligent album can help us automatically classify photos taken into categories like plants, food, people, buildings, and so on. And we don't need to manually pick images anymore. Image search, as the name suggests, is searching by image. So, if we don't know what content a picture is trying to convey or who the person in the image is, we can also search by image to find out. This is an application of computer vision in the express logistics industry, using artificial intelligence algorithms to automatically identify whether any violations of operations have been carried out violently on this express delivery. Next, let's introduce some scenarios of speech processing applications. The main topics of speech processing research include speech recognition, speech synthesis, speech wake-up, voice print recognition, audio event detection, and so on. Among them, the most mature technology is speech recognition, which can achieve an accuracy of 96% under the premise of recognition in a quiet indoor environment. Similarly, in some daily scenarios, such as our AI-powered intelligent robots in customer service, they can intelligently answer some of the questions we have. And at the same time, when using some voice navigation products, we also directly use voice to search for destinations. Here we will see more applications of speech processing, such as using artificial intelligence technology to synthesize a virtual voice for feedback and follow-up during phone calls, like in the case of return visits. Similarly, in other application areas, such as spoken language assessment. If you use an app, it can automatically help you detect whether the pronunciation is standard and whether the intonation is accurately expressed. This is also an application scenario of our speech processing. Next, let's take a look at some applications of natural language processing. Natural language processing mainly focuses on topics such as machine translation, text mining, sentiment analysis, and so on. The technical difficulty of natural language processing is relatively high, and at the same time, the maturity of this technology is relatively low because the complexity of natural language semantics is relatively high. Currently, it relies solely on deep learning algorithms based on big data and parallel computing. It is very difficult to reach the level of understanding of us humans, especially in our Chinese language, which has profound and extensive semantics, and one of its understandings. There are different levels, so for natural language machines, it will be very difficult for us to reach the level of understanding that humans have. From the perspective of the future development, natural language processing can derive from understanding shallow semantics to automatically extracting some features, and understanding the trend of deep semantics, that is, from a single intelligent. When it comes to hybrid intelligence, for example, we initially use methods like machine learning, and in the end, we can consider comprehensively. Machine learning, deep learning, or reinforcement learning are used to achieve our research in natural language processing. Next, let's take a look at some applications related to natural language processing in this area. For example, in our public opinion analysis, we need to dig into some themes of this text, or some analysis of hot events, and there are also some information distributions. And what my feelings were when expressing this sentence, there are also some trend analysis that can make use of natural language processing related technologies. Another common scenario is when we conduct transactions on some platforms. We'll first preview the evaluations of previous product transactions in advance. So here, we can use natural language processing to analyze this comment and its emotional tone. Is it positive or negative? Here, we will see the application scenarios of natural language processing. Listing. More types. First of all, we will commonly see machine translation. Then everyone opens the web page of Google or Baidu, or some of our translation software all can see such a translation function. So our language can be translated from Chinese to English, or translate text from Chinese to other languages, can be achieved through machine translation. In text classification, we can categorize these words. It belongs to different categories and corresponds to the respective categories. Next, there are some other things such as knowledge graphs, intelligent copywriting, video subtitles, automatic generation, and so on. That will also involve the use of technologies related to our natural language processing. So, artificial intelligence is an application in the direction of smart home. First of all, it will be based on IoT technology, composed of hardware, software, and cloud platform to form the ecosystem of our home. Providing personalized life services for users to make our family life more convenient, comfortable, and safe. We can see that, by voice, we can directly control the temperature, humidity, and other operations inside the home. At the same time, voice processing can also be used to control some products, such as adjusting this air conditioner. Switches, controlling the curtain switch, as well as voice control for the lighting system, and so on. By entering technologies like machine learning and deep learning, user profiles can be built based on the history records of smart speakers and smart TVs, enabling user-based personalized content recommendation. The artificial intelligence in an application in our smart city is reflected in all its aspects. In a smart city, our embodiment lies in social management, public services, industrial operations, and personal application scenarios. These can be seen as smart cities, encompassing various aspects of our daily lives, including clothing, food, housing, and transportation. In our retail industry, artificial intelligence also has a typical case. That is the unmanned supermarket, currently a more mature case of the landing of unmanned supermarkets. Everyone can see Amazon's unmanned store Amazon Go, which uses sensors, cameras, computer vision, and deep learning algorithms, and so on, to carry out the operation process of the unmanned supermarket, completely eliminating the cash register process in the supermarket, providing customers with a service that allows them to pick up in-store and leave immediately. One challenge of the unmanned supermarket is how to correctly charge customers. Here, we can see that there are many factors at play. If there is a need to establish such an unmanned supermarket, perhaps one needs to establish their own ecosystem first. Here, we will see that in various industries, we are facing our digital transformation. With the intensification of digital transformation, some of our artificial intelligence-related application technologies, it will also be reflected in various industries. Here is an example. That is, artificial intelligence is helping our energy coal industry, optimizing a coal coking formula. Next, we can see the current stage of artificial intelligence, including a stage it is about to develop. So when we talk about artificial intelligence, it has 3 stages. First of all, what we experience is the stage of our computational intelligence. In other words, it can calculate based on the stored data from the early stage. In other words, machines are beginning to calculate like humans. Being able to convey information to the stage we are currently at, this is the stage of perceptual intelligence. So the machine can understand and listen, make judgments, and take some simple actions. In the next stage, we hope that artificial intelligence can reach a state of cognitive intelligence. In other words, machines can understand, think, and make decisions like humans.